Today, we are presenting the company Ball Corporation. We provide our customers with aluminum cans. This is a raw material supplier. He supplies us with aluminum that is transported overseas to our factory in Colorado. The aluminum is then transformed into cans and held at our factory. The cans are finally bought by our customers. Some problems can arise along the supply chain, such as the bullwhip effect. The bullwhip effect is a phenomenon of demand fluctuations in multi-party supply chains, resulting in inefficiencies. It refers to increasing swings in inventory in response to shifts in customer demand as we move further up the supply chain. The bullwhip effect creates several inefficiencies, which endanger the whole supply chain. The main causes for it are: firstly, order batching. Due to the frequency of the orders given to the supplier, for example, larger orders placed less frequently create a fluctuation in the supply chain. As a second cause, we have demand forecast fluctuations, which arise due to individual forecasting of each member of the supply chain. Shortage gaming is another problem that occurs when customers place multiple orders for a product with one or more suppliers, or when they place an order for more than what they want. Finally, we have price fluctuations, which occur due to promotional discounts and sales. The problems caused by the bullwhip effect can be countered with the following remedies. Firstly, order batching. Instead of placing larger orders less frequently, one should place smaller orders more frequently. To remedy demand forecast fluctuations, we should focus on just one forecasting technique for all members of the supply chain to unify it along the whole supply chain. In order to counter shortage gaming, we can cooperate with customers and retailers as we share information. Finally, price fluctuations can be countered through EDLP, everyday low price, which means we stabilize constant low prices. In this video, we are going to focus on price fluctuations and the effects of discounts on our supply chain.
So here we have the numbers of Ball Corporation. As you can see, our order quantity is 630 tons per week, and our order costs are $1,800. Our discount is offered to us by our supplier in week 4. The orders to be placed can be calculated by this function. We start in week 3 with a beginning inventory of 1,260, which is the end inventory of the period before, week 2. Afterwards, we have the units received, which looks up whether an order is supposed to arrive in that week. The available inventory is just the beginning inventory summed up with the units received. Afterwards, we have our in-house demand, which is 630. This number is constant. Our demand filled is estimated based on whether our available inventory fulfills the actual demand. If the demand is not filled, we have a scenario of stockout. In this case, since our demand is constantly filled at 630, we do not have any stockouts. Our end inventory is based on our available inventory minus the demand filled. This gives the beginning inventory of the next period. Our units ordered are to check if an order has been placed in the week before. The orders in week 3 is actually 1, and we assume this because we want to build up stock. We have a lead time of 1 week. The arriving week tells us in which week the order that we have placed will actually arrive. Our inventory cost is our order quantity times the inventory costs. We do not have any stockout costs in our scenario, and the order costs are calculated based on this formula here. So now we take a closer look at the discount offered to us by our supplier in week 4. At the moment, we have a discount of 4%. This can, however, be easily changed by our suppliers to 5%, for example. And this will basically impact the orders we place. So how the orders are placed are calculated based on the discount offered to us in dollars, which is calculated by the discount rate times the order costs. And the orders placed are determined by a round function of the discount offered to us divided by our inventory costs. So then as our orders are placed in week 4, our end inventory plus order stocks up, and we will use that up. We will not place any orders for the coming next 6 weeks until week 11. In week 11, our if function looks at whether or not we have reached our reorder point. And since we have, this reorder point being 630, it will start placing an order. We therefore have our normal situation back again from onwards. This can also be demonstrated on this chart here. Our order stream is constant in the beginning until week 4 when our discount is offered. We have a peak. In the week after, our units ordered fall down drastically as we do not need to order anymore. We will use up the stock we currently have until week 11. In week 11, we will start placing orders again based on our if function. This can be a problem. The fact that we do not place any orders for 6 weeks creates uncertainty on the whole supply chain. Our supplier finds himself in a difficult position where he cannot anticipate our orders. He does not know our demand. We therefore need to help him anticipate this by creating a different scenario. Our in-house demand is 630. This is based on our customers' demand, which is constant at 630 tons per week. We sell it at a price of $2,000 per ton. This generates a constant stream of revenue of 1.26 million. Our solution to the problems presented by the generation of the bullwhip effect through the discount offered to us by our supplier is a promotion profitability scenario. Our basic solution is to hand a 20% discount to our customers in the weeks following the discount offered to us by our supplier. Based on historical data, we expect to sell approximately 100% more. This is shown through here. As you can see, we generate a slightly higher revenue. Therefore, in total, our profit is higher in the promotion profitability scenario. And also what you can see is that we have a scenario where we order actually faster again. So what happens is that we still generate the big bullwhip effect. However, we start reordering again faster in week 8 already. What this does is that it increases predictability for our supplier, and therefore they know that we will start ordering on a constant basis again. So we use up the stock generated by the discount offered to us faster in order to get back to a normal level. What we therefore deem important is to be as transparent as possible. We want to communicate clearly with our suppliers what our intentions are in order for them to adapt the discount offered to our promotion profitability scenario, and therefore understand how constant our demand is and when fluctuations happen and how fast we recover from them.